Welcome to The Explainer. Today, we're diving into a physics paper that makes a claim so bold, it could actually change how we see the universe's most basic rules.
Okay, let's just jump right into the deep end. On the left, you've got the official value for the gravitational constant, big G. This number comes from decades of our most precise, careful, real-world experiments. And on the right, that's a value predicted purely by a new mathematical theory. Now look closely at those tiny numbers after the plus-minus sign. That's the margin of error. The theory is claiming to be more precise than our best measurements.
So yeah, that raises a pretty big question, right? How could a bunch of equations on a piece of paper possibly know a fundamental number of the universe better than our most sensitive, real-world instruments? It kind of flips the whole scientific method on its head. To really wrap our heads around why this is such a big deal, we first need to talk about the main characters in this story, the fundamental constants of physics.
You can think of these constants as the universe's source code. They're the fixed, unchanging numbers baked into the laws of physics that make everything, well, work. They set the speed of light, the strength of gravity, the mass of an electron. They are the absolute bedrock of reality. And here's the puzzle that has been driving physicists crazy for more than 100 years. We've gotten incredibly good at measuring these numbers, but we've never had a theory that could tell us why they have the exact values they do. It's like we found the universe's instruction manual, but all the key settings are just listed with no explanation. We know the what, but we've been totally stumped on the why.
Now, this new theory isn't just taking a wild guess at one constant. No, it's making specific, testable predictions for a whole set of them, including big G, but also the mass of the electron and the mass of the proton. It's going for the whole shebang.
All right, so how on earth does this theory actually work? It's all built around an idea called the Universal Structure Code, or USC. Let's peel back the layers on this. The big idea here is that this universal structure code is like a Rosetta Stone for physics. It suggests there's a deep mathematical connection between things we've always thought were completely separate, like the messy, chaotic data from particle colliders and the clean, unchanging constants that run the cosmos. Okay, don't let the complicated math you see here intimidate you. What's important is the concept. This equation is basically the engine of the whole theory. It takes a bunch of different inputs from things we can measure, like what happens when particles smash together, and combines them to build one single, powerful predictive tool. And here we see that engine put to work. Once that mathematical tool is built, you can aim it at a specific target. In this case, it's using all that data from experiments to spit out a super precise value for the mass of an electron, calculating it from the ground up without ever needing to measure an electron directly. But look, a theory this wild needs extraordinary proof. You can't just show off some fancy math. So the author designed what is basically the ultimate final exam for their own model, a brutal pass-or-fail test with no partial credit.
The test was a blind validation, which is the gold standard in science, to avoid cheating, even accidentally. First, they used existing data to calibrate the model. Then, and this is the most important part, they completely froze it. Pencils down. No more changes allowed. Only then did they make their predictions and check them against the official values, using a checklist they'd agreed on beforehand.
So, how did it do on the exam? Well, the results were pretty stunning. The theory was put through 5 totally separate tests, checking everything from its statistical significance to its internal stability. And as you can see, it got a clear pass on every single one.
The really crucial thing here is that the model didn't just squeak by. It achieved what the paper calls global closure. That's just a fancy way of saying it passed all the tests at the same time, meeting every single condition laid out before the exam even started. It was a clean sweep.
A perfect score on a test like that is seriously impressive, but what does it all mean in the real world? Let's break down the numbers and what the bigger picture looks like. So first, let's look at the gains in precision. For the gravitational constant G, the theory gave us a value that was 1.18 times more precise than the official number.
Next up, for the mass of the electron, it delivered a gain of 1.12 times. And for the proton's mass, a gain of 1.13 times. The bottom line is, for all three, the theory produced a number with a smaller window of uncertainty than our absolute best real-world measurements have been able to achieve. But, and this is super important, the author is really careful to keep expectations in check. This quote here says it all. The result proves that this specific mathematical tool works incredibly well. It does not mean they've suddenly discovered a theory of everything that explains all of reality.
So the big takeaway is this. What we have here is a powerful, validated new tool for the physics toolbox. It's like a reliable machine. You put certain experimental data in one end, and out the other comes an incredibly precise prediction for one of the universe's most fundamental numbers. And we now have proof that it works.
And that, of course, leaves us with one last massive question. If this universal code can really calculate the hidden numbers of our reality from the ground up, what other secrets about the universe is it just waiting to unlock?